Hello. In this session, we are continuing on algebra and we'll look at some more past questions. The nth term of a sequence is 9n plus 4. Calculate the value of the term that is closest to 2012. 9n plus 4. Right. So the way to do this is to think about the meaning of this 9n plus 4. What it means is that when we say the nth term, that means that n can be 1, 2, 3, 4 and so on. N must be a whole number, right? So, and then for each value of n, you can calculate a value of this term, this 9n plus 4. So 9n plus 4 will take different values. Okay. Now when it said closest to, it suggests that it is not exactly. That means that there may not be a term that has exactly this value, 2012. But maybe there's a value which is bigger than that, and there's a value which is smaller than that, and this value might be in between two of the terms, and we want to find which one is closer. So if, for example, we could try setting this term equal to 9n plus 4 and solving for the n. This means we write 9 plus 4 equals to 2012. Now if this number on the right is exactly equal to one of the terms, then when I solve the equation for n, I must find an n that is a whole number. So for one of the whole number n, I should get that number if this is one of the terms in the sequence. But because this is not one of the terms, it means that if I solve this equation, n could be some fraction and not a whole number. So let's solve this and see what we find. Right, so we subtract 4 from both sides, get rid of that 4. 0.8, right, so that's when we subtract minus 4 from both sides. And then we divide both sides by 9. Okay, so this gives us 2008 over 9. We now need to turn this into either a decimal or a mixed number, a fraction with a whole number and a fraction next to it. Let's try that. 2008. If I divide 20 by 9, I have a 2. 2 times 9 is 18. So let's do a quick one. That's another. If I do 2008 and 9, that would be 2 times 9 is 18. Subtract from 20 gives a 2. Carry down the 0, that's another 2. 2 times 9 gives another 18. Subtract gives a 2 and another 8 there. And 3 times 9 is 27. Remainder is 1. So this gives me 223 and 1 over 9. So that's what I get. That's the value of n. And as you can see, it's not a whole number. Now it is 223 and 1 over 9. And what this means is that if I want to understand what this means, imagine writing down a table of these numbers. Okay. So, for example, if n is 1, I would calculate this number as 9 times 1 plus 4, which is 13. And you can do that for n is equal to 2, 3, 4, and so on. Now, what we want to do now is to do it for this term 223 and 224. Because 223 and 1/9 is in between 223 and 224. So this means that the 2012 should also be in between the two terms. And we want to know which of these terms are the closest to this. Now we can already guess that because it's 1 over 9, alright, 223 and 1/9 is closer to 223. So this is the term that should be closer, the closest to 2012. So let's find this term. Now, we want to find the value of 9n plus 4 when n is 2, 2, 3. So, right. So the answer is 2, 0, 0, 7. Plus 4. Should be 2, 0. 1, 1. Right, okay. Now, a quick way, well, we can do the full calculation, but just a quick way that we can do for this particular question is to notice that when we calculated the n just now, we find 2, 2, 3 and 1 over 9. Alright? And then 1 over 9 came from dividing by the 9, which came from here, the 9n. So when I divided by the 9, I got a remainder of 1. Okay, so what I did here really was to simply take away 1 from the 2, 0, 1, 2, and that gives me 2, 0, 1, 1. Okay, that takes quite a bit of guesswork, but let's do it properly. Now let's actually substitute the 2, 2, 3 into the 9n plus 4. You can either do it by hand or you can do it by calculator, and you'll find that 9 times 2, 2, 3 plus 4 would actually be equal to 2, 0, 1, 1. And then what you can do if you want to be very sure is to substitute 2, 2, 4 into that as well, right? And do this calculation, and you will find 2, 0, 1, 2, 0, 2, 0. You can do it by putting 2, 2, 4 into the n here and calculating 9n plus 4. But again, there's a quick way to do this. If you notice that because this expression is 9n plus 4, each time n increases by 1, this term should increase by 9 because n is multiplied by 9. So therefore, I can also get this term from the previous term by adding 9 to it. So 2, 2, 0, 2, 0, 1, 1 plus 9 is 2, 0, 2, 0. So now that we have these two terms, let's take a look at the question again. Calculate the value of the term that is closest to 2, 0, 1, 2. So 2, 0, 1, 2 is in between those two numbers. Alright, this is 2, 0, 1, 1. 2, 0, 1, 2 is clearly closer to 2, 0, 1, 1 than 2, 0, 2, 0. Therefore, this is the answer. 2, 0, 1, 1 is the answer. Next, part B. Calculate the difference between the 10th term and the 6th term. So now that we have a good idea what this sequence is about, we can do this. We can, for example, put in n equals to 10 into this formula and n equals to 6 into the formula, find the two values and then subtract them. So that's one way to do it. When n is 6 and 10, n is 6, 9n plus 4 is 9 times 6 plus 4. When it's 10, it's 9 times 10 plus 4. So we need to find those two answers and subtract them. Now, but there is a quicker way. If you notice, if you look at these two expressions before we calculate anything, you will see that there are many parts of these that look similar. There are the 4s in the two expressions and the 9 times. The only difference between them is the 6 and the 10. So a quick way to do it is to actually subtract them before you calculate them. Now what this means is that if I take this minus this, I can do it like I subtract equations or expressions in algebra. I can subtract the like terms. So 4 and 4 are the like terms. So when I subtract those two expressions, the 4 cancel. Alright, when I subtract them. Now you can already see that it makes things simpler. Alright, now the 4 is gone. Now if I subtract those two, okay, these are numbers, so there is not really any algebra down here. But from our exercises in algebra, you know that the 6 here and the 10 there, those are two numbers, okay? And then you have a 9 there and a 9 there. So the 9 is like a common term in the algebra. You have 6 of the 9 and 10 of the 9. So it's like 10 apples and 6 apples, if you think of the 9 as an apple. So if you do 10 apples minus 6 apples, you get 4 apples. So 10 9s minus 6 of the 9s gives me 4 9s. 4 times 9 is all I have. All I need to calculate. And the answer is 36. Now it looks more tricky, and it looks like it needs a lot more thinking than actually calculating each of the expressions separately and then just subtracting them. Especially if you have a calculator, right? But sometimes you can't use a calculator in these exams for some of the papers. So knowing a quicker way might help. And although it does look like you need a lot of thinking and it is quite uncertain if you will get it right, this will come with practice. Alright, with more practice, you can see the pattern and you can actually do it without going through the detailed explanations that I went through just now. If you look at these two expressions, you see the similarities and you simply subtract them like you do algebra. Okay, the like terms cancel. The 9 and 9 are common, so it's as if those two are like terms, and you just have to subtract the 10 and the 6, which gives a 4. Right? So once you think of it like an algebra, you can do the subtraction like you do it for equations in algebra, and you can get this 9 times 4 quite quickly simply by subtracting the 6 and the 10. Alright, you will pick those pick the 6 and the 10 out quite quickly once you have the pattern, and just subtract, just do 10 minus 6 to get a 4, and then you will get 4 times 9 quickly, and then you can get 36. So 36 is the answer to part B. Next question, part C, part 1. Find an expression in terms of x and y for the difference between the x term and the y term. This is slightly similar to part B that we saw just now. Let me think of the sequence. Imagine that this is a table of the values, and for the x term and the y term, the x term is when n is x, so the term is 9x plus 4. So here we are going into algebra. For the y term, that would be 9y plus 4. And we must find an expression for the difference. Now if you remember part B just now, this is beginning to look very similar. We have two terms and we must find the difference. Now that we have been through part B, we know what to do. We need to subtract those. So 4 and 4 cancels. We have 9y minus 9x. Now why should we do 9y minus yx instead of 9x minus 9y? Well, in this case, when we do a difference, we would usually take the bigger number minus the smaller number. But in this question, it does not tell us whether x and y is bigger. So I'm just going to make a guess. It also means that it does not matter which way you do it. So let me just assume that y is the bigger one. If I take 9y minus 9x, I get 9y minus 9x. That's what I get. I might simplify that and write it as 9 times bracket at y minus x. By factorizing it, by taking 9 out of a bracket, I can also write that in this form. But in this case, either way to write it is fine. The question does not actually ask you to factorize it. That's part 1. Part 2. Part 2. Hence, explain why it is not possible for any two terms of this sequence to differ by 123. Right, now we know from what we know of a sequence, it is a series of numbers, and when you take the difference between the numbers, you get certain values. So we can we can see that it is possible why certain numbers are not given by taking a difference between the two of them. Alright, because the sequences are made up of some fixed numbers, not just any number. Now, but to do this question, we need to make use of the previous parts in this case. Now, in the previous part, we have found an expression for the difference between two terms, x and y. Now, one thing to remember here is that x and y must be whole numbers, because x and y are values of n, which is a counting number, right? So x and y must be whole numbers. Now, if 1, 2, 3, if 123 is a difference between two of the terms, now we don't know which two terms they are, so we can say that we let those two terms be x and y. Okay, so suppose that these are the two terms, x and y, then if the difference gives 123, it means that this, the 9y minus x, is equal to 123. Okay, if, that's the big if that we need to check. Now, but what are we going to check really? If you look at this and think about this like an equation, then the unknowns are the y and the x. Now we have two unknowns here and just one equation. So we can't do simultaneous equation to solve for the x and y. But there is one thing that we could notice. I said just now that because this is a sequence, because n is a whole number, x and y are whole numbers. But that also means that y minus x must be a whole number. Let me emphasize that. This must be a whole number, because it is a whole number minus a whole number. And if you think of x minus 1 as a number, as a single unknown, right? Remember, we can do that for everything inside a bracket. You can imagine that everything in that bracket can be calculated and gives you a single answer. So we can think of the whole bracket as a single number or a single unknown. So if you think of this as a single unknown, the y minus x, we can think about solving for that unknown. And then if we think of y minus x as just one unknown, we can solve this equation. Alright, we can divide both sides by 9. And the idea is that if we can solve this unknown, will we find a whole number? Because y minus x must be a whole number. And that's the question. Because if it is a whole number, then it means that it's okay. But if it's not a whole number, then that answers the question. So let's calculate y minus x. We divide both sides by 9. Right. So on the left side, the 9 and the 9 cancels, because this is 9 times number divided by 9. So 9 and 9 divide themselves and gives 1. And on the right side, I have 123 over 9. 123 over 9 is 123 divisible by 9. Well, 123 is divisible by 3. So let me do the cancelling here. If I divide by 9 by 3, I get a 3. If I divide the 12 by 3, I get a 4. 3 by 3, I get a 1. And I have 41 over 3. Is 41 divisible by 3? Not really, no. 41 divided by 3 is... Now the closest number divisible by 3, which is less than 41, is 39. Because you have a 3 and a 9, so 39 is divisible by 3. If you divide 39 by 3, you get 13. 39 divided by 3 is 13. But then you're left with 2. Alright, because 39 is 2 less than 41. So 13 and 2/3 is the answer. It is not a whole number. What we just found is that x minus y is not a whole number, and therefore it is not possible for x and y, for any two terms, to differ by 1, 2, 3. Now because x and y are used to represent any two terms, so therefore x and y are the any two terms. And in this way, we have the answer. Alright? If you have to write this down if you have to explain your answer in the working, what you would say is, because x and y are whole numbers, so y minus x must be a whole number. But this calculation shows that if the difference between the two terms is 123, x minus y cannot be a whole number. So therefore it is not possible for the difference of two terms to be 123. That's how you do this question. We are moving on to another question. The sequence of positive integers is arranged in the pattern below. That's row 1. So row 1 is 1, 1, 2. This is row 2. It's 2, 4, 5. Row 3 is 3, 7, 8. And row 4 is 4, 0, 11. Now, here you are given row n. Now that is blank. That column is left blank. And that term is now 3n minus 1 in terms of n. You have to complete row n. Complete means that clearly this is the missing bit that we need to fill in. And we have to look for patterns. If you look at this second middle column, it goes 1, 4, 7, 10. Now notice that the difference between every two terms is 3. Alright, 1 plus 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. So each time we add a 1 as we go down, starting from the first number. Right? So in order to see how to make up a sequence like that, what we could do is to think about a term given by, say, 3 times n. Because each time we go down one row, we add a 3. Alright, and if you keep adding the 3, when you go down to the nth row, you would have added n times of 3. 3n. So that's the idea, that's the reason why we should think about 3n. Think about this expression 3n. Now, just to make it clearer what 3n looks like, what it means to think about this, let me make another row where the numbers are given by 3n, and let's calculate that and see what it looks like. So for row 1, if it is the formula is 3n, I will have 3 times 1 for the row 1, 3 times 2 for the row 2, 6, 3 times 3 which is 9, 3 times 4 which is 12, and so on until my nth row is just 3n. So if it is 3n, if the n row is 3n, this is what the column looks like. Now compare this column with this one. You see that if 3, 6, 9, 12 and so on, this is 1, 4, 7, 10. Now if you look at those two, this number 3 is more than 1 by 2. 6 is greater than 4 by 2. So this is always bigger than this by 2. Alright, so I should be able to get this if I take 3n minus 2. Okay, and this is what we can do, and we can always check that 3n, in fact we should always check that 3n minus 2 is correct by calculating some of the terms. Meaning, for row 1, substitute 1 into the n here and check that you get 1. For row 2, substitute into the n, you get 3 times 2 which is 6 minus 2 gives you a 4. So that's how you can find the nth term for this. So let me quickly summarize this. There's quite a lot of reasoning that I went through. What is the quick way to see the answer? The quick way, right, let me start from the beginning again, is to say that, right, I notice that each time I go down one row, or each time I go to the next term, I add a 3. So if I add 3, I get 4, add 3, get 7, add 3, get 10, and so on. So if you notice that there's this fixed amount that you add each time, this 3 that you have to add each time, then there must be a 3n in this nth term. There must be a 3n, because each time the n increases by 1, the answer increases by 3. So there must be a 3n involved. So that's our first step. Okay, so if you think of it this way, you already have part of the answer. You have the 3n. But then 3n is not the answer, because for example, in the row 1, it's not a 3. Right? If 3n is the answer, then the row 1 must be a 3. But you have a 1. So instead of a 3 for 3n, you have just a 1 for the row 1. So you must add or minus something from the 3n. And the number to minus is 2 if you want to get a 1. Okay, if when n is 1, 3n is 3, and in order to get the first term, you have to minus a 2. So this is the quick way to do it. And with this idea, because the difference is between terms is 3, you get 3n, and to get the first term, you have to minus 2. You can then go on to check 3n minus 2 for the next 2 or 3 terms, just to make sure that it is correct. And that completes the row n. Let's look at the next part of this question. Part B, the table shows some results obtained from this pattern. Now, what we have here, okay, there's quite a lot of details there. This is what we have. We have row number 1, 2, 3, 4, dot, 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 n. We have square of the middle number in the row, and we have the numbers 4, 25, 64, blank, x. Product of the first and the last number in the row, 3, 24, 63, and y. Part 1. Complete the column from row 4. In order to do this part B of the question gives us an additional column in the first table, which is this column. So the table here refers to this table. Okay, so this column of numbers on the left is just a row number, okay, and not the actual table of numbers that we need to look at. So for part B includes an additional column, which is this column that is given in the question, that is given for part B. So now, if we think about this table, in row number 1, the square of the middle number in the row. Now the row number 1 is this row, the middle number is the 2. So the square of the 2 is 4. So now we understand the 4. Product of the first and the last number in the row. The row is this row. First number is 1, last number is 3. Product is 1 times 3, which is 3. So we can understand that. So let's just check that we got this, we understood this correctly by looking at the next row. Row number 2, which is here. 4, 5, and 6. Square of the middle number in the row is 5 squared. That's the middle number of this row, and 5 squared is 25. Product of the first and last number in the row. First number is 4, last number is 6. Product is 4 times 6, which is 24. And you can check for yourself that for row number 3, the 64 and 63 are correct. So now that we are quite clear about the meaning of this table, we must, in part 1, complete the column for row number 4. And row number 4 is here. That's the row. We must find the values for those two blanks. Okay, we must fill in a number there and a number there. And the number here is the square of the middle number in the row, which is the square of 11. And that's 1, 2, 3. 123. Product of the first and last number. Product of 10 and 12. 120. So we have done this part. in the next part 2, find an expression in terms of n for y. Y is that n is the row number. Right, so we are talking about row number n, which we already have, that's that row. And we want to find product of the first and the last number in the row. First number is 3n minus 2, last number is 3n. So therefore, y is 3n minus 2 times n. First number, last number. Right, there's a 3 there as well. Let me put that here. So that's the answer. 3n times 2n minus 2. That. Now there is a last part to this. Let me find some space to write it. I shall clear this part off because we still need this table. Part 3. Show that y minus x minus y, and that's not very clear, x minus y is always equal to 1. That is x, that is y. X minus y is what we need to find. Now we already know y in terms of n. We need to do this question, we must also find x in terms of n. X is the square of the middle number in the row n. The middle number is that number is 3n minus 1. So x is the square of that, 3n minus 1 squared. And x minus y is that minus that. So we have some algebra to do here. Should be able to clear out this whole lot now. This is the last part of the question. So what we need to do is to find x minus y. And x is 3n minus 1 squared. And y is, I'll write that as 3n times 3n minus 2. 3n bracket 3n minus 2. So we have an expression and we have to simplify it, and hopefully we will get 1 in the end. So let's start work on this. 3n minus 1 squared. To do this, it would be easier if I use the formula directly. Now the formula that I need, let me write this somewhere. The formula that I need is a minus b squared is equal to a squared minus 2ab plus b squared. Now we can of course expand this in the usual way, just multiplying together all possible terms or using the methods of removing the brackets. But that takes longer, and it is always good to be familiar with this formula. Alright, a minus b whole thing squared is equal to this, because we see it quite often. So let's apply this formula directly. A is 3n, b is 1. So the first term, if I expand that, is a squared, which is 3n squared. Next term is minus 2ab, minus 2a, that's a, so minus 2 times 3n times b, b is 1. So that's what I have, plus b squared, which is 1 squared, just 1. Now, and in the next, for the next term, I need to remove the brackets. Now we must always be careful if there is a minus sign in front of the bracket, because that changes the sign of each term in the bracket when we remove the brackets. So let me do 3n times 3n. 3n times 3n is 9n squared. The minus sign. So the minus sign now changes the sign of the 3n to a minus. And then I have 3n times 2, which is 6n. And the minus sign must change the minus sign to a plus. Next step, I must simplify each term. 3n squared is 9n squared minus 2 times 3n is 6n plus 1 minus 9n squared plus 6n. And we need to look for like terms now to further simplify this. You have a 9n squared there and then minus 9n squared there, so they cancel, and we have a minus 6n and a plus 6n, and they cancel to 0, and we are left with 1, which is the answer, because we need to show that x minus y is always equal to 1, and we have just done that. What this means is that when we say that x minus y is always equal to 1, it is always in the sense that it is equal to 1 for any values of n. Alright, it does not mean that it is always as in for any other questions as well. Of course, x and y can have other values in another question, but for this particular question, always means for any value of n. So it is, one must be careful, we must be careful when we see the word always, because the word always can be confusing. So in this case, what we see is that after doing all this calculation, all the n's cancelled off, it's disappeared, and this is what we get in the end. I will finish here for this session. See you next time.